So we had to restart the stream. I realized after about 7 minutes that my microphone wasn't registering. So we're back at it again. I'm just kind of delaying to make sure that I can hear my audio, and then we're going to keep going. Okay, it seems to be working this time. All right, so this will serve as the this will be the lecture for week 6 Friday for support for college algebra. Only real announcements. 1, be sure that we've completed the participation and honesty quiz on Moodle, and then 2, basically get your assignments on Pierce and get them submitted. I do intend to reduce the late penalty from 20% to 10%. I think I did run into a hiccup, but we should be able to get it done. There should be a way to get it done. Let's see. Yeah, and my intent is to load as many of the remaining assignments for the rest of the quarter as possible. I think I want to go up to section 6.7. So I think today we're going to be doing section 6.4. And I do want to kind of go ahead and load the final as well to give you some time to work on that. So my intent is to load all the remaining assignments for the quarter. And you get unlimited attempts. You can actually earn an A on any assignment that you want. So since we're not doing extra credit, I'm okay with giving you access to the assignments. Okay, I'm okay with this. Keep in mind, I am available for questions, and okay, let's just kind of keep moving forward. So we want to continue the discussion today with chapter 6, rational expressions and equations, with section 6.4, adding and subtracting rational expressions with unlike denominators. I think last time, let me see, last time we looked at adding and subtracting rational expressions with common denominators. Now we want to see what are we doing when they have unlike denominators. I'm going to let you go through this on your own, and I'm just going to work a few examples, right? So if we want to add, it's just like adding fractions where we have to get a common denominator, right? So what we want to find is the least common denominator. So I think last time we talked about a technique or method for finding the least common denominator. So first we want to write each denominator in factored form. So if we have this 4x squared y, 4 is 2 squared times x squared times y. 14xy cubed is the same as 2 times 7 times x times y to the power 3, right? So the LCD here is going to be, we need to take one of every different factor, right? So that means we need the 2, we need the 7, we need the x, and we need the y, right? And then we take the highest exponent on any factor within one term, right? So for the 2, the highest exponent is the 2. For the 7, the highest exponent is 1. For x, the highest exponent is 2. And for y, the highest exponent is 3. So the LCD in this case is going to be what? 28x squared y cubed. So then what this is saying is that we can get both denominators to look like this, all right? So what we're going to do is multiply each fraction by 1 in the appropriate form so that we can get the denominators to look like this, right? So let's start by getting a copy. We got this 4x squared y under 1 plus we got this 14xy cubed under 3. So we want to multiply both fractions by 1 in the appropriate form so they finish with this denominator. So if we look at the first term or first fraction, we already have our x squared. If we need y cubed, that means we're going to need to multiply by the top and bottom by y squared. For the 28, we're missing a 7, so we need to multiply by 7. So is it safe to say that we're really just multiplying by 1? Is it safe to say that something divided by itself other than 0 is 1? So we're really just multiplying by 1. So we're not changing the answer. We're just manipulating the form so that we can do what we need to do. And then for the one on the right, let's see. So we need a 2 to get to 28. We need an x to get to x squared, and the y is already proper. So we're going to multiply the top and bottom by 2x, okay? So then if we account for these changes, on top, we're going to have 7y squared plus 6x. On bottom, we're going to have our 28x squared y cubed, okay? And that should be it there. Let's see, how do we do? We got 7y squared plus 6x over 28x squared y cubed. Okay. Let's try another one. So again, factors are things that we multiply, terms are things that we add, right? So if we look at that first denominator, if we have x plus y, x plus 2, that's already factored, right? So those are two terms, so we leave them like that. And then the second denominator is x. So in this case, the LCD is going to be x plus 2 times x. Okay. So then we have this x plus 2 under 3 plus 5 over x. We want both denominators to look like the blue. So this one we're going to multiply by 1 in the form of x over x. This one we're going to multiply by 1 in the form of x plus 2 over x plus 2. Okay. All right. So then if we do this, on the left we get 3x, on the right we get 5x plus 10, and this is all over this x times x plus 2. Combined like terms, we get 8x plus 10 over x times x plus 2. Even if we factor out a 2, we'll get 4x plus 5 and nothing is going to cancel. So I'm going to leave it like this. 8x plus 10, x times x plus 2. Okay, you see it there. All right. Okay, so with this, it's a good idea. Maybe try pausing the video and see, can you, first, can you identify the LCD on your own? If you can identify the LCD, can you get the two rational expressions that have the same denominator? And see how far can you take it on your own before I do it. Okay? Because as long as you're following me, you're not gonna get it. You have to kind of get the idea and then try it yourself. Right? Also, we need to be sure that we're attending at least 2 hours of tutoring every week. Okay? So I'll get the spreadsheet from the tutor on that, and that will be factored into the grade. Yeah, I can't think of anything else. Okay? So the LCD here, we need the w minus 7 times the w minus 4. Okay? So then, again, we have this w minus 7 under w. We have minus w minus 4 under 6. And we want both denominators to look like the blue. So this one is missing the w minus 4. So we have to put that on top and bottom. This one is missing the w minus 7 on top and bottom. Okay? So then if we account for these changes, let's see. Over here, we're going to have w squared, because what I'm doing, I'm distributing this w here. I'm distributing this negative 6 here. Okay. So we're going to get w squared minus 4w minus 6w, 63642, all over w minus 7 times w minus 4, right? Let's keep going. I'm going to continue over here. We have w squared minus 10w plus 42 over w minus 7 times w minus 4. So then we want to see, can we factor this? All right, can we factor it into something of this form? This persists, this persists. So we're looking for two numbers that multiply to give us 42 and add to give us negative 10. Let's see, 6 times 6 is 3642. Okay, so what I'm going to do, I'm going to go through my factors. So if we look at the 42, 42 is what? 6 times 7? This is 42. So this is 2 times 3 times 7, right? So we could say 1 times 42, but that adds up to 43. We could say 2 times 21, but that adds up to 23. So that's no good. We can do 3 times what? 14, but that adds up to 17, so that's no good. 3, 4, 5, and then 6 and 7 I think is it, and that adds up to 13, so that's no good either. So with that, we are actually going to stop with this answer here because I can't factor this further with integers. Okay. Let's see, how do we do? Okay, and that's where we stopped. Okay, so notice here, when we go to find the LCD, notice these denominators are essentially the same, but they're kind of in reverse order. So do you know what we need to factor out? We need to factor out a -1. Let's factor out -1 from that right denominator. So this is going to be the same as we have this x minus 5, x plus 2. If we factor out a -1, I'm going to write it in the following way. It's going to become x minus 5. I'm going to move the negative to the top. I feel like that's just easiest to see. Notice if we distribute a negative into the denominator, we get the denominator on the left. So now we have a common denominator. 2 minus 3 is -1. So ultimately we're going to get x minus 1 over x minus 5. And that's it. Okay. Looks like they have a typo. That second line is supposed to be x minus 5. They're supposed to be the same. So like here, once they distribute that negative on top and bottom, this should become x minus 5. But the final result should be proper. Okay. So here, let's look at each denominator. Let's factor first. So let's start with this x squared minus 6x. Again, we want to find the LCD, but first we have to get it in factor form. So what's the greatest common factor? What do these two terms have in common? We can factor out an x from both of them. And we're going to be left with x minus 6. Okay. So then let's do this other one. We have this 6x minus 36. What do they have in common? We can factor out a 6. And we're left with x minus 6. Notice in either case, we're done. We stop with multiplication, or we end with multiplication, right? So then when we go to find the LCD, we got to take one of every different factor. So that means we need the 6's by itself, we need the x's by itself, and we need this x minus 6. Factors are things that are being multiplied, right? I think the highest exponent on all of these is 1, so this is our LCD. Okay. So we want to transform both denominators to look like this. The first one we have, I'm going to write it in factor form. We have this x times x minus 6, and that's under 6. And then the second one, we have this 6 times x minus 6. That's there's a minus here. There's under x. Actually, I'm going to write it like this just to keep track of that a little bit better. And then now the first one, we have the x minus 6, so we're missing this 6. So we're going to multiply the top and the bottom by 6 there. The second one, we're missing the x, so we're going to multiply the top and the bottom by x here. Okay. So then on top, now we're going to have 36 minus x squared over 6x times x minus 6. Okay. So that top can actually be factored because this difference is squared, so that's going to factor into 6 minus x times 6 plus x, okay, over 6x times x minus 6, okay. Notice we have two factors that are similar but in reverse, so we're going to factor out a -1 to account for that. So then this is going to become -1 times x minus 6 times x plus 6 over 6x times x minus 6, okay? So now this cancels this, and we'll finish with negative, I guess we could say negative x minus 6 over 6x. Okay, I'll leave it like this. Okay. Yeah, that's the same thing that we got. Okay. All right. So that's all I wanted to do today. We don't necessarily do a lot on any given day, but a little every day goes a long way, right? So if you kind of procrastinate and wait to try to do all this, you're going to be completely overwhelmed. I mean, it's kind of a mute point at this moment in time. We have a little over 2 weeks remaining in the quarter, so you just have to do your best. You have to make a decision, make a plan, and execute the plan. Okay. So and be careful about waiting to the last minute to submit assignments on Pearson, because the closer we get to the deadline or the due date, it's going to crash. It's going to slow down. It's going to not work, and so that's why I try to have this stuff as soon as possible and try to give you as much time as possible, because the closer we get to the deadline, the more likely Pearson will not work. Okay. On that note, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.